So hello again from my side. I'm very happy to provide one of the input talks for this workshop, which I gave the title Anonymizing Health Data under the GDPR. And what are some challenges that I see and also experiences that I have with this. As you can see from the title of my talk, my experience is mostly on the GDPR regarding the legal side, and of course prior to the GDPR, the German data protection law, but it's not actually that different in many regards from the GDPR as I see it. So the first slide I prepared has to do with terminology. We already had a terminology discussion, and we also had discussions on terminology in the preparatory calls to this workshop. That's why I thought it might be good to say something about terminology in the GDPR. So what terminology is used in the GDPR? There are terms like personal data, identified or identifiable person, anonymous data, and pseudonymization. So that's already quite interesting to take a look at the terms that are not used in the regulation. These are mostly process-oriented terms, right? So for example, the term anonymization or anonymized data is not actually contained in the GDPR. Instead, the GDPR talks about data that has been rendered anonymous. So it's a state of data and not a process. And this is also, I think, quite helpful to distinguish also between the legal perspective and the regulatory perspective, because anonymized data is often understood as a data to which an anonymization process has been applied. And an anonymization process is often also understood as a very simple process where you, for example, just remove names without necessarily rendering data anonymous in a legal sense. Also, the term pseudonymized does not exist. It's the term pseudonymization only, as far as I know. And of course, the terms de-identification or de-identified or coded, coding, and so forth are also not used in the GDPR. And there are a few principles that I think are that are also mentioned in the GDPR that I think are relevant when we're talking about anonymization. I think such as lawfulness, fairness, transparency, and so forth. That's not really relevant here. But data minimization is an important concept within the principle within the GDPR, and to some degree also storage limitation. And these are also areas where anonymization techniques can be of interest, even in cases where you're not able to produce anonymous data or render data anonymous. You can use this to minimize the granularity, for example, or degree of identifiability of data that is handled in research. Now, what is anonymous data according to the GDPR? I think this is also quite interesting because the GDPR actually mostly talks about personal data. There are very few cases where data that has been rendered anonymous is mentioned, but anonymous data is basically understood as the opposite of personal data. And as soon as you have anonymous data, you fall out of the scope of the GDPR. So the GDPR assumes that you can do something to personal data, and as an output, you get data that has been rendered anonymous, and this is not covered by the GDPR. Now, the question, of course, the most important question in this context is what is actually personal data, right? And personal data is defined in, or it's not defined, but there's recital 26, which tries to sort of give you an understanding of what the GDPR thinks about the concept of personal data. And here it is said that personal data is basically any information concerning an identified or identifiable natural person. And then, of course, the next question is, what does it mean to be identified or identifiable? And here, recital 26 says that when thinking about whether or not data is identified or identifiable, you should take account of all means that are reasonably likely to be used to identify a person. So that's already the point where probabilities and likelihoods and also risk-based perspective comes into play. And it's also further specified which aspects are relevant when you reason about whether something is reasonably likely, because in this regard, we should take or consider all objective factors. For examples that are mentioned are costs or the amount of time that is required. And also to do this identification, also quite interestingly, you should take a look at technology at the current point in time, but also consider how technology might change in the future. So this is a legal definition that is quite hard to capture technologically. And just to give you one example of how anonymization might look at the technical level, this is a very simple example where tabular data is anonymized. And here you can see that anonymization in this regard is a process that uses an input data set, in this case a table, which consists of personal data, and outputs another data set that is rendered anonymous, in the best case also in the legal sense. And there's a very wide variety of different modifications of data or any different types of processing that can occur. In this case, it's a combination of taking a random sample, aggregating some values, removing some values, truncating or masking some values, categorizing values, and also generalizing values, in this case, for example, diagnoses. Now, the problem, of course, here is immediate. It's immediately clear. The resulting data set has significantly changed as compared to the input data set. Now the question remains, what is this output that is hopefully rendered anonymous in a legal sense actually useful for scientific purposes? And this brings us to one of the most well-known, but also the central challenge in data anonymization, the fact that there is an inherent trade-off between the degree of protection that you can achieve, so a reduction in risk of data being identifiable, and on the other hand, the degree of utility or usefulness that a data set has, for example, for scientific purposes, because you need to change it, and in some cases change it significantly in order to achieve a high degree of protection. So, and also in this trade-off, what immediately also comes to mind or becomes obvious is that interpretation of the law is something that now becomes really important. If I try to find a good trade-off between protection or the production of anonymous data, I need to know what does it actually mean to protect data or to reduce risk. So this comes back to the question, what is personal data? What is identification? The GDPR does say something about this, but it's not something that directly translates into technical implementation options. And also, of course, there is no thing such as zero risk. There will also be some residual risk left, and this raises the question of what is an acceptable risk threshold. So how high can the probability or likelihood be that something does go wrong, although we have applied anonymization techniques? And on the scientific side, it's of course important to understand what is the planned use, for example, of a data set. What are requirements that researchers have that plan to work with the data? And we might need to consider this when anonymizing data in order to come up with a data set that is really useful for scientific purposes. And you can plot this on a very simple abstract graph where you have the protection here and you have the scientific utility on the x-axis, and there is of course an extreme point up here where we would have no risk, so a data set perfectly rendered anonymous and also perfect utility, but unfortunately this does not exist, because whenever we change data, we perform some form of transformation or any type of processing, there's something that happens to utility and risks. And if we have a good anonymization method, we are moving somewhere on a graph that looks like this. So we are able to come up with a high degree of protection and at the same time also have relatively high scientific utility of the data set. And of course, we don't want to do this. So we don't want to protect data sets so much that there's no scientific utility, because then we would do bad science or come up with bad new knowledge that is actually not correct. There would be significant bias within data sets, for example. But also on the other hand, if we're really aiming to anonymize data in a legal sense, in this case regarding the GDPR, if there's too much risk or how we measure risk does not align with what the law expects us to do, then we are of course breaking the law, and we also want to avoid this. So this already gives you an idea that from my perspective, anonymization is something that is inherently context dependent. It has to do with the purpose of a data set. It also has to do with the recipient, but it also has to do a lot with types of data. We had a slide on this before. This is just, these are just a few more examples to provide you with insights into the different techniques that are already needed to produce different types of data sets. So this is an MRI scan, for example, of the brain, where you can apply defacing techniques. If you're dealing with textual data, the only thing you can typically do is to remove specific identifying or sensitive tokens. You might also need to anonymize biosignal data. There are specific techniques for this. Also for genomic data, for typical structured data, for example, billing data sets, you can use more mathematical models to sort of more formally measure and reduce risks, which is more different for data that has less structure. There are also specific algorithms that deal, for example, with statistical tables, because also data that is the result of a scientific analysis, for example, or any other scientific processing, there might also be a need to take a look at the privacy risks or the anonymity of the data that is the result of such a process. So what guidelines can we turn to? And there are actually quite a lot of guidelines out there, and some of them applying more qualitative processes, others recommending more quantitative processes. This is an example of a few guidelines that I'm aware of. In particular, this is a selection of guidelines that mention the anonymization software that my group is developing. So here are some examples from the European Medicines Agency or the European Union Agency for Network and Information Security, guidelines from the UK, from Australia, from France, and so forth. So many different institutions took a look at this and tried to come up with an overview or a set of recommendations. But from my perspective, there's still this inherent challenge that most of these guidelines are quite vague. They do recommend, which makes sense, a context-specific approach. But on the other hand, this also doesn't make them very actionable quite often. So you really have to come up with your own process of how you anonymize a specific data set if you're really aiming for legal compliance. There are a few tools, and I already mentioned that my group is developing one of the more well-known tools that are available. What are anonymization tools here with a specific focus on structured data? They can be seen as software tools that try to sort of automatically or semi-automatically solve this risk-utility optimization problem. A few of them, or actually quite a lot of them, do support various different types of mathematical and statistical models that can help you to quantify risks and quantify data utility. And of course, this also makes them sort of independent of a specific law or a specific interpretation of a law. So this is also something that you typically have to do when you use such a tool. You have to reason about the specific risks and what mathematical or statistical procedures you can use to measure those risks, and then reduce them using anonymization techniques. There are, of course, other jurisdictions. So if we talk about HIPAA safe harbor, for example, there might be tools that focus specifically on the requirements that are laid out in this law. But many tools, as I said, provide a wide set of different techniques. You wanted me to provide some recommendations. I do, of course, I have to recommend my own tool, which is ARX. It's basically a comprehensive Java programming library, but also a standalone graphical tool that you can use to process individual level tabular data and to anonymize it, so to perform various types of transformations and assessments of risks and output data utility. And it implements quite an automated process. At least the graphical tool, the programming library, can of course also be used to implement different steps on an anonymization process in a quite flexible manner. But there are also other tools, and I would specifically recommend to take a look at the STC tool suite, consisting of STC Micro and according graphical user interface, and also STC Table, which are packages for the R statistics programming environment, also focusing on individual level data in the case of STC Micro, but also on statistical tables in the case of STC Table. This tool is much less automated than ARX and has fewer models that are supported and fewer functionalities, but it's also quite popular. One slide on the graphical front end of ARX, which you can see here. ARX is divided basically into 4 perspectives. There's a perspective where you can load a data set and configure your anonymization process, and it provides you with an exploration perspective. If you think back on this risk-utility trade-off that needs to be done, ARX presents you basically with multiple options that provide you with different trade-offs, and you can then select options and further analyze them to see how, for example, the anonymization process has impacted statistical properties of a data set, but also how risks have changed according to different mathematical models that are implemented in the software. So the software has been quite successful. As I already mentioned, it has a comprehensive set of features, including traditional approaches such as k-anonymity, which many of you might know, but also more innovative approaches such as differential privacy or game theoretic approaches, and also a few methods for creating privacy-preserving machine learning models, in particular classification models. It's quite scalable, so it's actually much faster than all other anonymization tools that I'm aware of, and has also been used to process really large data sets with billions of records in cluster installations. It does have the graphical tool that I just presented, which is frequently used for training purposes, and has been used in a wide range of contexts to produce open data sets that you can download on the internet, but also to build anonymization pipelines, for example, in the telecom or health insurance fields. It's quite industry friendly, has been integrated in quite a few commercial products, and the algorithms have also been adopted by other vendors. Now, I would like to use the last 5 minutes that I hope that I have to present you with an application example. So how did we recently use ARX in this case, but it's just a tool. It's more about the process to really anonymize a concrete data set. In this case, from a European registry that captures the clinical course of patients with COVID-19 that has been established at the University of Cologne. The registry has quite a specific or special concept that was implemented to quickly react to the COVID-19 or SARS-CoV-2 pandemic. So there's a retrospective documentation of mostly independent study sites that document all patient data retrospectively, and informed consent has been waived by the IRBs of all participating institutions. And the underlying idea is to sort of follow an open science approach. So the registry is hosted in a secure environment. No identifying data is ever entered into the registry. And then anonymous data sets are shared with researchers and the public. And for this case, additional anonymization procedures have been implemented. And my team collaborated with the team in Cologne to develop those anonymization pipelines. So the first, I think, strategic decision that was made was to develop 2 different types of data sets. There is a public use file, which is a limited data set with 16 variables that is made available to the public without any restrictions. And there is a range of scientific use files with up to 605 variables that researchers can request to access under data use contracts, so having an additional contractual safeguard in addition to the actual anonymization process to deal with residual risks. The pipelines have been built with ARX. There's 2 stages for the public use file and 10 stages, so much more complex for the scientific use file. And I won't go into any further detail here, but we also have implemented quite an interesting process based on synthetic data sets that were generated in Cologne, which allowed us to develop those pipelines without actual access to the data that is stored in the registry in 7 iterations over a few weeks. Now, and so what did we do here? And that would be one of my first recommendations. We combined qualitative risk assessment approaches with quantitative risk assessment approaches. So first we took a look into laws and guidelines and selected mostly a list of risky variables and compared those variables to the variables in the data set. Already at this point, we figured that the risk of re-identification is actually quite low. But we still decided to complement this qualitative assessment with a quantitative assessment. And in this process, there's quite a nice methodology that has been proposed by Brad Malin, which we have here today as well, and colleagues, where you can classify variables according to their associated risk of or potential risk of identifiability by reasoning about the replicability of data, how available it might be to recipients, and also how distinguishable it makes the patients in this case that are reflected in those in the data set, and use this process to come up with a set of potentially identifying variables in the data set, and which we then decided to anonymize. And here again, we took a look into guidelines and recommendation. There's an opinion on anonymization methods by the so-called Article 29 Data Protection Working Party, which today has been superseded by the European Data Protection Board. And they said that you should deal with the risk of singling out. So that's the possibility to isolate records belonging to certain individuals. Linkability, which refers to the ability to link data sets to each other. And also inference, which is quite hard to tackle. So the possibility for attackers to deduce with some significant probability the value of an attribute from other values that are in the data set. And we mitigated those risks by applying relatively, I would say, classic or traditional anonymization procedures. And we use k-anonymity to prevent singling out and linkability, which is also recommended in the opinion. And in addition, T-closeness to protect medical attributes from inference, that has also been recommended in the opinion. And yes. And also quite interestingly, these documents or these data sets are published repeatedly. So we also had to deal with the fact that privacy protection might be broken when you repeatedly publish different versions of the data set. So we decided to use a static data transformation scheme and just withhold records that do not fulfill the privacy requirements until they can be added to the public data set in this case. And what we also did is, and I would also recommend this when developing a guideline, we produced extensive documentation. So the GDPR, as I mentioned, follows a risk-based approach. So we created a document where we clearly describe the underlying considerations taken, what are the different risks and threats that we see, and how did we counter them for this specific data set. And we also released the code of this pipeline as open source software. What we also did is we continuously monitored the data quality, and because this does have some impact, of course, on data utility, as I mentioned, but as it turned out, I will jump to this slide, this sort of negative impact quickly really diminished basically, and at the current state of today, there's basically a negligible impact of anonymization on data utility. You can see this here, as I mentioned, records are withheld, so not released or withheld, not released in the data set if they do not fulfill the protection requirements. So in the beginning, when the data sets were initially published, we had to withhold around 40% of the records, but then this number quickly went down, and today the data sets that are being made available contain almost all records that are available from the registry, and also the according bias and the properties of the data set is basically non-existent today. This is an example here for the case fatality rate, and you can see that there were significant differences in the beginning, but today there's basically no difference between the data in the registry and the data that is being released. This is somehow counterintuitive and has to do with the fact that these privacy models, k-anonymity and also T-closeness, are based on the principle of hiding in a crowd. So the more records you have available, the more easier it becomes to make sure that individuals are not too different from a larger set of individuals. Just go back one slide and I'm almost done. And this is the schema or the set of variables that are contained in this public use file, as I mentioned, consisting of 16 variables. And what did we do with the scientific use file? The scientific use file is basically an extension of this process with 8 additional pipeline stages that implement transformations for various other parts of the data set. And these are more like rules of thumb that are used here. We categorize metric variables, we make timestamps relative, regroup or suppress some sensitive variables or sensitive values. And these different stages or modules can then also be combined with each other to come up with protected data sets that are suitable for the needs of scientific researchers from specific biomedical domains. So the overall approach is very context specific. It's adapted to the concrete data set. There are multiple layers of safeguards. These layers are qualitative and quantitative methods that are being used. We relied significantly on recommendations from LEOSS and other guidelines. And I also believe that this risk-based approach really requires you to come up with thorough and detailed documentation in addition to a protected data set. And now I think I'm a little bit, I talked a little bit too long, but that was my last slide, and thank you for your attention.